let's apply this method in problem 1. Make an NPV comparison of an eco-service machine for which the costs are shown below, and we call MAR. So what is MAR in this case? So my minimum attractive rate of return, and then you can see, go back to review in the first lesson videos for today. So my minimum attractive or acceptable rate of return. 10% per year, and you have two alternative machine type A: initial cost, annual operating cost, and service values. Service values is basically the estimated amount or the values to resell an access at the end of its useful life. So service values is the estimated resale value of an access, in this case the machine, at the end of its useful life, in this case 5 years. 5 years, and you can see the life for the machine is 5 years. It always, to do this evaluation alternative, we need to use the first we need to draw the cash flow diagram. Okay, so that's very important. So draw the cash flow diagram for each machine. So type A, let's see type A and type B. So we have for type A 5 years, so you have that one. And years from 0 to 5. And then initial cost, type A, it's 2,500, so cost going down 2.5k, that case 4,000. And then annual operating cost 900, so it will be also down, the cost going down. And we have 1, 2, 3, 4, 5. It's already there. So it realized for the cost or the income normally realized at the end of the period. So at year 1, first year will be at the end of that year. So it's on the 1, as you can see there. And that is 900 annual operating cost, 900 per year. The service values, like I say, is the estimated resale value of an access. So it's that you get the money, so go up at the end, and that is $200. So that is for type A. Machine for the cash flow diagram. And then similarly, we have type B machine with the same method of drawing the diagram, and this one also 5 years. So 0, 1, 2, 3, 4, 5, and it's the initial cost, so it at time 0 we spend 3,500, 3.5k. Operating cost, operating cost 700, and same amount over, so that you have that is and same amount, that is annuity, and that is 700 per year. The service values is 350 at the end of year 5. So that is the cash flow diagram for machine A and B. And then you just go ahead to by definition the net present values to transform the future receipt or expenditures into equivalent dollar nows. And we have two alternatives and have to be same the number of years when you compare. In this case, we have 5 years. So both machine have 5 years, same number of years. That's good to prepare. So transform the money for each alternative into the dollar now, which is the present value times 0. So that we can find out the first NPV, net present value of type A machine. And in this case, all the money, future, expenditure, income, bring back to time 0. So the first is the 2500. That is at time 0 already. So you don't need to put any factor in. And it going down. So you have that is negative 2500. Because that's your expenditure. And then you have to spend operating costs 900 per year, same amount over 5 years, that we call it annuity A, and you can see that. So that here actually the A, annuity, in the equivalence equation that we learned in the previous lesson. And same for 700, same amount at the end of period over and over. So that we have to bring that money, A, 900 per year, to time 0 present. So it means that we use the factor know the annuity A, find the present value P. Then that's why we can have that negative, because spending operating cost 900. And then you time a factor. What factor we use? We know A, 1 to 5 P, because that transforms the future, the present value. P, given A 5 P, what is the percent we have? Percent in this case is 10%, so that you have it 10%. Why? Because that is, you see, MAR for the alternative here is 10% per year to compare. How many years? It's spent for 5 years. A lasts for 5 years. So that we have 5 years. And then the service value, 200, and it go up. So we have it plus 200 value, $200. And then that is one single amount. At year 5, we want to transform that to the dollar now, which is the time 0. So $1 single amount in the future, go back to the present, so that you have given F 5P, because we know F. So you time the factor P over F, 10%, 5 years. And when you have that, you can use the exam reference, and that is your to find out P over A 10% 5 and P over F 10% 5. For those of you who are not familiar with those factors, go back to the previous lesson, equivalence equation formulas, to know how to get that factor. So let's go to down to here. So P over F 10% 5 and P over A 10% 5 years. So you can put P over F, you can have equation here, 1 plus I power negative n. If it P over 8, then you have that equation there, P over 8. Make sense? But that, you don't want to use that equation. I, in this case, 10% for the MAR. You can go to the table, and now I'm going to use the table. Look for the table of 10%. Look for the table of 10%. See that here? And then we can look for the 5 years. 5 years. Because that's what you have n. P over 8. That factors, that is P over 8, 10%, 5 years. And then P over F. 10% and 5 years. So that the two number we can just write down here. So we have that in negative 2500 minus 900. That factor P over A 10%, I just show you that equal to 37908 plus 200, and then the factor there equal to 0.62 0.6209. Go back again. That is the two factor we have. Make sense? So P over F, P over A. Then we just multiply to get that numbers equal to negative 5,787.54. Similarly, now it become slow in the first, but now you can do faster for B with the same negative 3,500, negative 700 per year, and that is A. So we can have the same time factor P over A 10%, 5 plus service value 350 factor given F 5P, P over F 10%, 5. And those factor the same as the previous one, so we just plug in, and PVB negative 3,500, negative 700 time 3.7908 plus 350 service value time 0.6209, just the same factor, so this should be the same numerical value, so it will be negative 5,936.25. So there are two NPV, so two alternative, one is negative 5,785, the other is 5,936. Which machine we are going to choose? Two or more mutually exclusive alternative. Go with the alternative with the greatest NPV. Between these two number, of course, you see this is negative. So the apparently the type A machine only have to spend equivalent dollar now 5,787.54 cents. Equivalent dollar now for type B 5,936.25 cents. So that you spend less on machine A, so it's better to go A. So that you can see from that I have NPV A greater than NPVB, because that's the negative number. So from that, what we can do, we can choose type A machine, and that answer. Okay, so that is the first problem with the net present value.